Good morning, everyone. Can you all hear me clearly?
Good morning, sir.
Yes, sir.
Good morning.
Cl-
Good
Very
Clearly
good.
morning.
audible.
Very,
Yes, sir.
very good.
Yes, sir.
Excellent. Okay, so let's start this week with programming fundamentals class. So in the last week, I had introduced the concept of pointers to you. So I have this board open, which I had left it since we left, for the weekend. And looking at what's written on this board, we had touched upon the concept of pointers. Okay, so we will be looking at pointers today also, and we will be looking at pointers in a more structured way. All right, so I think we can start. Fine. So I told you in the last class, right, that pointers are related to addressing, right? And I also told you that the memory inside your computer is used to hold the binary code of your program, like which can consist of statements, data, and so many other things, right? So whatever you write in the program, all the data, the code, everything is stored in your computer, right? And it is stored in the form of a binary code. All right. So every memory location on your computer must have a unique address so that the computer can read from or write to that memory location without any confusion. Okay. Now this is similar to the concept that in every house in a city must have a unique address. This is similar to that concept. So when you declare a variable, say int a, I'm declaring a variable here. A piece of unused memory will be reserved for that variable, and the unique address, so this will have some unique address. This location in the memory will have a unique address. Okay, the address has to be unique because no two houses on this planet has the same address, right? So even in the memory, no two location will have the same address. That's why we call it as a unique address. So if each memory location must have a unique address. So when a variable is declared, a piece when a variable is declared, a piece of unused memory will be reserved for the variable, and the unique address to the memory will be associated with the name of that variable. Okay, that means this A will be associated with this address. Now, this A is nothing but a user-friendly name for this address. Okay, it's a user-friendly name. Right. So this is the address, which is basically a unique number, and the name of the variable will be associated with this address. Okay. Now the address associated with the variable name. So this address, which is associated with this variable name, the variable name here is A. It is usually called as the left value. It is called as the left value of the variable. So in this case, our variable is A. So this value, this is also a number, right? It is also a number. I'm writing it in the binary form, but this is a number. This number is also associated with A. Now this number is called as the left value of the variable. So in this context, we are talking about the variable A. Now, when the variable is assigned a value, let's say A is equal to 7. Now, what I'm doing here is I'm assigning the value 7 to A, right? When the variable is assigned a value, this value is stored into the reserve memory. So this value is stored into the reserve memory. Okay, and this value which is stored into the reserve memory location is called as the content. So this is the content. This is the content. Okay, so inside the container, this is the container. The container has got a memory address, which is this. And inside the container, we have a value which is called as the content. All right. Now this content, that means the number 7 here, is called as the right value. Right value of A. Okay. So this is the right value of A, and this is the left value of A. Okay, so the variable a actually has two different types of value. One is called as the right value and the other one is called as the left value. The left value is nothing but the address and the right value is nothing but the content which is at that address. So here the left value that I've written it as 10101 is actually the address of the memory location which is reserved for A, right? The right value, which is 7, is the content which is stored in that memory location. Now, please note that depending on computers and operating system, this left value, which is left of A, this 10101, this is what I've written it as an example, can be different from one machine to another. Okay, now you can imagine this as your, you can imagine the variable A like a letterbox in front of your house, okay, which has got an address. And that address, what is that address? It's 10101. And what is the right value? 7. 7 is the actual letter which is delivered into your letterbox. Okay, so it's very important to understand this concept of left value and right value. Now, when your C program is being compiled and a value is being assigned to the variable, the C compiler has to check the left value of the variable. If the compiler cannot find the left value, it will throw an error. That means the variable is not defined in your program. That is the reason why we must declare a variable before we can use it. You just can't use the variable. You have to first declare it. Let's imagine, what do you call, a postman which comes to your house, complains that he or she cannot drop the letters to you because you don't have a letter box. So in order to accept the letter, in order to you know get the letter from the postman, you must build a letterbox. So without building a letterbox is like declaring a variable, and in that variable you actually put your letters, so you actually put your content. Okay, so I hope you've understood this concept of right value and left value, because this is an important concept. So every variable has got two different values associated with it, the left value and the right value. Okay, so moving ahead, we will talk about now an operator which is called as an address of operator. Okay, address of operator, and the symbol of this operator is the ampersand sign or the and. Now the C language provides you with this operator in case you want to know the left value of a variable. Okay, so suppose I declare, say, int x is equal to 10. Now I know the right value. Right value is very simple to get, right? The right value is the content which you're actually putting inside this variable, which is the value 10 here. But if I want to know the left value of x, that means if I want to know the address of that memory location where this content is stored, then I need to make use of this particular operator. Okay, this operator is called as the address of operator because it evaluates to the address. That means it will tell you the left value, and left value is the address. So if you look at a code, let's say int x is equal to 10, right? And I had explained to you in the last class that you can also declare a variable with star. So when you declare a variable with the star, it means that it is a special variable. Now this is the variable which will store the left value. That means it will store the address. Okay, so in order to store the left value of any or which is also the address, you need to declare a variable with a star. And this variable, that means y here, is a special variable which is called as a pointer variable. All right, so what is y going to store? The y is going to store the x value, sorry, the left value. I'm sorry, the y is going to store the left value. Now if I want to store the left value of x, then I must first extract that value. Now this address of operator is going to help me find the left value of x. So the right value of x can be directly found by looking at the value of x. But if I use this address of operator and if I write x here, that means this is going to give me the left value. What is the left value? Once again, it is the address. Now I can store this value into this variable y. Why I can store this value? Because this is a special variable which is used to store the left value of any other variable. Okay, so this address of operator is a very important operator. Okay, now we will be discussing about this operator later on also, but for now you must remember that this operator is the address of operator, which actually extracts or lets you know the left value of any variable. So in this case, the variable in question is x. So if I just have x, it represents the right value, which is 10. If I do ampersand x, this is the operator, right? What it is going to give me? It is going to give me some address, I don't know what this address is, because this will be decided at at different times. So if you run the program 5 times, it may happen that your value is stored in different parts of the memory. So this address will keep changing. All right, so is there anyone who has a doubt related to what I have told you right now? Did you all understand this concept of left value and right value?
Got it, sir.
Let me know so that I can go ahead. So everybody is
Sir,
clear
can
with
you
left
repeat
value
the
and right
last
value?
part?
Since
Yes, sir.
last part, this part,
Sir, from INT point.
this one. So every variable has got two values, okay? One is the left value and one is the right value. So when I talk about x is a variable, okay? X is a variable. Now this x has got two values. One is the left value and the other one is the right value. What is the right value? So when I write x is equal to 10, the right side value is this 10, which is the content, okay? Which is the right value. This 10 is the constant. 10 is the number that you're storing. Now, where are you storing? You're storing in some memory location. So this is the memory location where you're storing the value 10. Now, this memory location will have some address of its own, right? It will have some address. So let me say that address is 101, right? Now, this address will also be associated with x, because this x is the variable for which this address has been allocated. So this x will have two different values that it will know. One will be the 10. So if anybody wants to know what is the value of x, if you print x, it will give you a value 10. The second value that this x will also have is this 101, because that is the place where your value is stored. That is the container or the memory where that value is stored. So this value which basically is associated with the address of the memory location, that value is called as the left value. So left value is basically the address where this particular x is the value, the right value is stored. So the right value 10 is stored in the address which is denoted by the left value. So every variable x, y, z, any variable that you declare will always have two values. One value is the right value and the other one is the address, which is the left value. Okay, so if you look at this line, int x is equal to 10, this is the right value. But where is this stored? It is stored in some memory location, some address. What is that value of that address, or what is that address? That is also kept by x. So although in this line we don't see that, we can only see the right value, but x also is associated with another value, and that value is called as a left value. So how can I find the left value of x? How can I find the address of where x is stored? So in order to find that, I have the address of operator. So if I do ampersand x, that means if I use the address of operator with the x variable, then this is going to give me the address where the 10 is stored. That means this is going to tell me the the left value of this variable x. Okay, now since this part is nothing but the address, I can store it in another variable. What is that variable? Y. Now y is a special variable which is called as a pointer variable. Why it is special? Because this y is not a variable which is going to store your normal numbers, but it is a special variable which is also declared by this star. Every time you declare the special variable, you are declaring with a star. That means it indicates that this variable will only store the left value or the address of any other variable. So in y, I cannot put the value 5. Okay, this 5, integer 5, 10, 15 is incorrect. What should be stored should be the left value or the address of any other variable. So in this case, I am storing the address of x in this variable y. This y variable is declared with a star, which indicates that it is a pointer variable. What are pointer variables? Pointer variables are those variables which will only store the left values of another variable. What are left values? Left values are the addresses where the actual values of that variable is stored. Am I clear now?
Yes, sir. Yes,
Pointer
sir.
Yes, sir.
variables are
Yes,
repeated.
sir.
Repeat it again.
Sir, pointer variable.
Okay, pointer variable. Fine. So what is a pointer variable? A pointer variable, suppose I have int x. Okay, I have int x. Int x is an ordinary variable. Why it is ordinary variable? Because it can be used to store integers like 10, 20, 10, 15, whatever it is, right? But we know, we have discussed now that, can you please mute your microphone? Yeah, Sai Subhranshu, can you mute your microphone? Okay, thank you very much. So yes, so I was telling you, what you were asking me, what exactly is a pointer variable. So x is a normal variable, ordinary variable. What is x? Ordinary variable. What is this x? What happens to x when I declare int x? In memory, a space is allocated to x, and that space has got some address. All right, it's got some address. Now this, when I initialize the value 10, that means this 10 is stored inside this memory location which is allocated for x. So x will be mapped to this. That means this is the address of the memory location which is mapped to the variable x. Okay, so if you look at x, x has two different values associated with it. One is the value 10 and the other one is the address of the memory location where the value 10 is stored. Now this 101 is called as the left value and the number 10 is called as the right value. So all the left values are nothing but the address of memory where the actual value or the content is stored. Right now, in order to handle these left values, so in order to handle left values, okay, which is nothing but the addresses, okay, you require a special variable. I can't do int x and store this value inside x. I can't do that. It is not possible. So I need a special kind of variable. So I will declare a special kind of variable with a star. Now this variable is called as a pointer variable. Why? What is so special about this pointer variable? This pointer variable is only used to store this value, the left value. You can only insert the left value in a pointer variable. You cannot put the right value inside the pointer variable. That means, how can I find the left value of any variable? So I told you in the previous page that in order to find the address or the left value of any variable, so suppose x is a variable, I need to use the address of operator. So if I use the address of operator, I will get 101, which is the left value. Now this left value, I can put it inside P, because P can only be used to store the left value or the address. So this P, which is used to store only the left value or the address, is a special variable, and that is called as a pointer variable.
Excuse me, sir.
Is this
Sir,
clear?
having just a doubt.
Yes, please.
Sir, is it mandatory that the pointer variable is going to use when the arrays come into the scene, or we can use
Array.
it even in a normal condition?
You're talking about
So,
array?
no, no, sir. I'm talking about that. Is it mandatory that we are going to use pointer variable if arrays come, or can we use pointer variable in like a normal condition?
Yeah, I can use pointer variables in normal condition. And why we are considering pointers is because it gives you a flexibility. Okay, it gives you a
Yes, sir.
flexibility that we will see later on, basically how exactly pointers help you. So because of the flexibility, you can actually, pointers are used in C programming in a variety of way. So we will look at the application of pointer, but we can use it in any way, without arrays, with arrays, with files, everywhere you can use pointers, or you may not use pointers, but pointers give you a lot of flexibility in C. That is why pointers are used.
Okay, sir. Thank you, sir.
Okay, so if I have to look at a simple program, right, I'm just writing this main.
Sir,
So
can you show the page again? Previous page.
yeah, this one.
It's just a minute.
Yeah. Anyway, you don't
Sir,
need to actually work. Yeah, tell me.
I had a question.
Yeah.
If we don't use a pointer variable to store our left value, if we use normal variables like x, y, or something else, can we
Yeah.
store left value?
No, you're saying that in place of P, can I use some other values?
No, I mean, can we store left value and some other values rather than pointer values?
No. You should not. You should not. Okay, that means
Left
only the
values
left.
should be always left values should be always stored in pointer values or pointer
Yes.
variables.
Absolutely. The left value should always be stored in a pointer variable. The left values are always stored in a pointer variable.
So done.
Yes, okay.
Okay. So you should not be storing your left values in any other variable, no normal variable. Okay, so let me just show you one simple example. I'm not writing that hash include and all that stuff, just to, make sure that you understand it really well. Now, if I have a character C, okay, and if I have an integer, say X, right? So I can actually initialize a value for this C, right? So I can write C is equal to A, or I can write X is equal to 10, isn't it? Now, what are these A and 10? Are they left values or right values?
Can you repeat it, sir?
What
Right
is
values.
Sir, right value.
They're right
right
values.
values, right? So everybody is right.
Right
So
values,
these
yeah.
are the right values. Okay. So along with this, now there is a left value. What is that left value? That left value will be this is the memory location, right? So A is the right value, 10 is the right value, right? Now, this X will be associated with one address. Let's say it's 101. C will be associated with an address here, which is say 105. I'm just putting a random number here. This is the address. Okay. So now, if I need to know these values, how do I know? How do I know? I will need to
We
use the
use
address of
and
operator.
And operator.
Absolutely. So if I need to know the address, so I will be using AND operator with C. And in order to know the left value of X, I will need to use AND operator with X. Everybody's clear? Now, if I want to just print those values, I can directly do printf and put this. It will print the values. Okay. But if I want to keep it in a container, that means if I want to take this value and I want to keep it in a container for using it later on, then I need to declare some kind of variable to store it. And I know that that variable will be a special variable, which is a pointer variable. So I can say that, let's say this is a pointer variable for C, and let's say there's a pointer variable for X, which is going to store this. So now when I look at these pointer variables, I need to declare these pointer variables, and these pointer variables need to be declared by using that star. So when I want to store the left value for a character, so in this case, I am going to store the left value for a character data type. So when I declare the pointer variable, I have to declare it with a character, char. So p underscore c will be declared with a character. Okay, but here I'm storing the address of a variable which is an integer type. So when I'm declaring the pointer variable, I have to declare it with an integer. So here, let me declare it with an integer. So p underscore x is a variable which has to be declared as an integer. Now remember one thing, in these variable, when I use the data type, it means that C and X are variables which are going to store the data which is of type character. This is going to be X, which is a variable which is going to store the values which are integers. That means the right value for C will be a character, the right value for X will be an integer. But when I do char pointer P or int pointer Q or float pointer R, the values which are going to be stored in P, Q, and R will be of the same type. What will be the type? It will be the memory address, and the memory address will be a fixed defined type. Okay, but what do these indicate? These indicate that P is going to store the address of that memory allocation, that memory address where a character will be present. Q will be storing the address of that memory location. Okay, Q will be storing the address of that memory location where an integer is present. And R will be storing the address of that memory location where a floating point number is present. So this meaning with a pointer variable and the meaning of this with the ordinary variable are different. Did you understand this?
Yes, sir.
Okay, please remember this. This is a very fundamental difference. That means character C stores a character value, but character P does not store a character value. What it stores? It stores the address of the memory location where there is a character value. Okay.
Sir,
So
please say again. Again, please.
again, okay. So when I write int x and say float y, okay, and I'm going to initialize with 10 and here 20.5f. All right. Now let's say I'm going to do p. Now, when I declare two variables, one is floating point and one is integers, that means this is my memory. This is my memory, okay? This is my full computer memory. Here is my memory, okay? Assuming that this is how memory is allocated. And let's say my address is starting with 100, 101, 1023, 104, 5 1 106 108 110, and this is 111. Okay, so this is my address. Now when I do int x is equal to 10, say my 10 is allocated in this memory location. Okay, so for x, what is the left value and what is the right
100.
value? Absolutely.
The right
So
value is
x
10.
left value will be 100 and the right value will be 10, right? Now suppose y is allocated here. So 20.5f is allocated here. So for y, what is my right value and what is my left value?
Right value is 20.5.
And my left value is going to be 106,
6.
right?
Yes, sir. Yes, sir.
Everybody's okay till here?
Yes, sir. Clear.
Okay. Now, if you look at it, let's say I have another char. Sorry. Okay. Let me include another char. Char z is equal to, let's say, a. Okay. And I'm going to do char r. So let's say my char is going to be allocated somewhere here. So my a gets allocated here. So for my char, which is z, my left value and right value, let's see what it is. My left value is going to be 111 and my right value is going to be a. Right? Everybody is okay with this much?
Yes, sir. Clear.
Yes.
Okay. Now look at it. When I have declared the variable z, I have mentioned a character. That means what I'm specifying here is what is the type of r value that I'm going to have. So when I say character z, what I'm trying to say here is what I'm telling the compiler or what I understand here is that z value is going to store the right value, which is of type character. X value is going to store the right value, which is of type integer. And y value, the y right value will be the type float. That means all the three are different types. So your right value here is an integer. Here your right value is a floating point number, and here right value is x. Now these three different types. So this is character, this is floating point, and this is your this is your char, this is your integer, and this is your floating point. These three are defined here when we are declaring the variable. Okay, but if you look at these three lines now, here I have written a pointer variable r, p, q, and r, and I have mentioned character, integer, and float here, right? But if you look at the values of your left values, that means r, p, and q are only associated with the left values, right? So if you look at the left value, here it is 100, here it is 111, and here it is 106. Okay, there is no difference that 100 is character, 106 is float. The addresses will be the same, isn't it? The addresses will be the same. 100, 106, and 111 are the same data type. Here it is not changing, but we are writing character, integer, and float. Why? What we are writing here is we are telling that R is a pointer variable which is going to store the address. R is a pointer variable which is going to store the address of that memory location. Now R is going to store, let's say R is equal to ampersand Z. That means R is pointing to which memory location here? It is pointing to the memory location where Z has been allocated. What is that value? A. So R is actually pointing to this memory location. Okay. So R is pointing to this memory location where the value of Z is stored. So by writing ampersand Z, I'm trying to access 111. So the value of R will be 111. Which value will be this? This will be the left value of Z. So when I write character R, the meaning is that R is going to store the address of that memory location where a character value is stored. When I say P, and I have written here as integer, this means that P is going to store the address of that memory location where an integer is stored. What about Q? Q is going to store the address of that memory location where a floating point number is stored. So did you understand this?
Yes, sir.
Okay,
Yes, sir.
Yes,
all
sir.
right. Okay, so I have explained it, very thorough and very, slowly. So everyone should probably have understood this. If you have not understood, you please go back and view this. I will upload this video, and you can actually go through it once again because this chapter is important. All right, so we know how to declare a pointer variable. We know how to declare a pointer variable. So all of you know you can declare a pointer variable like this, right? What is the meaning of this? It means that P is a variable. What kind of variable? A special variable. Why special? Because it will store only the left values of another variable. What are left values? Nothing but addresses. So what does this line mean? This line means that P is going to store the address of another address of a memory location. So P is going to store the address of a memory location, okay, this value, where a character is present, which is going to store a character. Okay, so I cannot do this. I cannot do this. I cannot declare, excuse me, just okay, so I cannot do int x is equal to 10, right? And I cannot do char p and p is equal to ampersand of x. This is wrong. That means what I'm trying to do here is I am allocating a memory, storing this 10. This has got an address, this one. I'm declaring a pointer variable. This pointer variable is supposed to store the memory address of that. It's going to store the memory address of a variable where a character is stored. But what I'm trying to do is I'm trying to store the memory address of a place, a location where a character, no, it's an integer is stored. So this is going to be wrong. Okay, so this example is incorrect here. So what I need to do is I need to remove this char and I need to write an integer. That means now P is a pointer variable which is going to store the address of a memory location where an integer is stored, and it holds good. But so if you are declaring a variable as x, which is an integer, and if you want to do this, then you have to declare p also as an integer. Okay, so that's a very important concept. Now you can try this in the lab. I can try and give you, try out whatever I'm trying to do here. You can try it out in the lab. Okay, and if you want to put another thing that I need to tell you is when you're trying to print out the address, right, you try one thing. You can use, excuse me, you can use the format specifier as %p. Now you know that %d is for printing out integers, right? And you know that, right, %d is used for printing out integers. So if you want to print out the address, you can use %p. So if you have a printf statement, so if you're going to write a printf statement like this, printf, and you want to print the address, all right, so you can say the address of a is equal to, you write %p, all right, and then here you need to specify the address. So you can straight away, if you have a variable called as x, and if you're doing x is equal to 10, you can straight away, if you write ampersand x, it will print the address of that memory location where the value x is stored. Alternatively, what you can do, you can take another pointer variable as p, right, and you can assign this address of x into p, and then you can directly, what you can do here is you can directly print, say, let's say, just to make it clear so that there is no confusion, I'm going to write just ptr. So let's write ptr, and I can directly write ptr, and this is going to print the address. Okay, that the value that is going to be printed in this case is going to be different for all of you. That depends on your operating system, that depends on your system, where exactly in memory your operating system will allow the allocation. That depends on your own system, so everybody will get a different answer. And in most cases, your address that is going to be printed out is going to be printed out in the hexadecimal format. You know what a hexadecimal? Have you studied hexadecimal?
Yes, sir.
Yes,
Okay,
sir.
very good, very good,
Yes,
excellent.
sir.
So hexadecimal, very good. So the value that you're going to get printed out is going to be in the hexadecimal format. Okay, if you want to see this in a decimal format or an integer format, you can change this format specifier, and you can write D here, and then the value that will be printed will be the decimal format or the integer format. Okay, so the integer. So by default, P will print in the hexadecimal. Now what you need to do is, this is an important concept, so unless you run the program, you will not be able to understand it. Okay, so it's very important that you actually write a small code for this, whatever we are doing here, so that you have an absolutely clarity on whatever concept that we are discussing. Okay, so I'm going to tell you one more thing. So let's say I have an integer x is equal to 10. All right, so what's going to happen? Here is my memory location, right, which has got some address. So I'm writing the address in binary right now. All right, and this is going to have value 10 here, and x is going to be associated with this, right? Now, important thing here, let's declare a pointer variable. So let me declare another pointer variable. So here my pointer variable is ptr, so I need to declare it as an integer. This is absolutely clear. Now what I can do is, if I do percentage x, what is the value that I'm going to get? Sorry, not percentage, ampersand x, I'm going to get the address, which is the left value, right? So x is going to give me 10, and ampersand x is going to give me 1010, and I think everybody should be clear here. Okay, so now the question is, I have something in the memory. I have something in the memory. Okay, now what is the value which is there in the memory? The value that is there in the memory is 10. Now there are two ways by which I can access that value in the memory. There are two ways. One is if I know the name of that memory location. So x is nothing but a name given to this memory location. All right, x is nothing but a name given to this memory location. For example, let's consider all of you. Once you join college, once you join a school, you have been allocated with a roll number. All of you have your roll number? Yes, unless you have a roll number, you will not be given you will not be allocated into the memory of KIIT. So think of, a roll number as your address. Okay, and along with your roll number, you also have a name, right? Now, what exactly is this name? Name is a kind of a friendly, just say a friendly name for your roll number. So, for example, if I want to contact you, there are two ways I can contact. I can either use your name or I can use your roll number. That means I can either use X, which is nothing but a name, to access the value. So if I want to find your age, suppose I want to know your age. So I can say I can use your roll number. I can say roll number 106753. What is your age? You will say, sir, my age is whatever, 20. Other alternative is I can ask you your name. I say somebody say Rahul. Rahul, what's your age? So he will say, sir, my age is 20. So if you notice, there are two ways by which I can access your value. So there are two ways by which I can access this 10. What are the two ways? One way is by using the name, that is X, and we have been doing that, right? We have been doing that. One way to access this value 10 is by X. That means if I write printf, right, and I just write X, I mean, I'm not writing the entire syntax, and this syntax is incorrect, but just an example I'm giving you. So if I do printf X, what is going to get printed? 10. Okay, so I have used the name to access this value, but I can also use this address to access this value. That means address, think of an address as a roll number. So I can use your roll number also to access this value. Okay, so how do I do that? How do I do that? So assuming that PTR is the address, okay, because the address of X, which is ampersand X, which is the address of operator, right? Now PTR is holding what? It is holding this value 1010. Now my challenge is, my task is, how can I access 10 using PTR? Because PTR is holding the address. So one way was I straight away access the value of 10 by using the name. That is, Rahul, what's your age? In the second example, I'm trying to access Rahul's age not by calling out his name, but through a roll number, that means through his address, through PTR. So how can I find the value 10 using address, which is basically holding this number 1010? Now this is possible. In C, you have an operator which is again star. Now, you ask anyone, you ask any person, like, what is so complex in C, and they will tell you pointers. Why pointers are so difficult? The pointers are difficult or because people don't have a fundamental understanding of this concept. And the other reason why it's difficult is because the same symbol is used in different contexts. For example, you have the same symbol used in three different contexts, in three different ways, having three different meaning. Now, if you are not able to distinguish between those symbols, depending on the usage and depending upon what they actually intend to do in different contexts, then you will be confused. And that's why people find this concept of pointers very confusing. Remember one thing, this star, which is the star of pointers actually, because this is what defines your pointers, also makes things complex. People who don't understand, they see stars because of stars. Now this star has got three different meanings in C programming. One, it is used for multiplication. Okay, the star is used for multiplication, and all of you know that. So if you do A star B, that means we are trying to do multiplication. So this is used as a arithmetic operator. Everybody understands that? Everybody understood that? That star is used as a
Yes, sir.
arithmetic operator. There is another usage of star. What is that another usage of star? Another usage of star is to declare a pointer variable. We use the star here, right? Another use is declare pointer variable. So when I write star PTR, the star meaning is different here. We are not using star to multiply, but we are using star to tell that this PTR is a special variable. Why? What's so special? Because it will hold only the left value. What is this variable called? Pointer variable. So in the second instance, you have star, which is used to declare pointer variables. It is used for multiplication. It is used to declare pointer variables. And now we bring the third meaning of star. The third meaning of star is that it can be used as another operator, and that operator is called as decrease. dereference operator. What is this dereference operator? Now this, you all understand this? You all understand this. Now what exactly is dereference operator? Now, dereference operator is used to find out the value or the right value using the address and not using the name. That means if I write star PTR now, okay, so in place of printf, if I write star, one second, if I write star PTR, okay, this will give me the value at that address. That means it will derefer, the reference means address, dereference means value at that address. So address is held by PTR. So PTR, what is the value stored at PTR? 1010. So if I write star PTR, what is it's going to do? So star is going to be used here as a dereference operator. So what this operator will do, this star will find the value that is being held at this address. So PTR is holding which address? 1010. 1010. So if I write star PTR, that means it is going to, this operator is called as a dereference operator, and it's going to find out the value which is being held by this address. So star PTR will give me 10. PTR will give me 1010. Okay. So the third form of, star is in the usage of dereference operator. So if I have to explain this once again, let's say x is equal to 10. This is an integer. Okay. Now I'm going to do star p, which I'm declaring a pointer variable, right? So sorry about this. Okay, I'm just declaring a pointer variable. Now when I do p is equal to ampersand of x, I am taking the address of x and I'm putting it into p. Now if I do star p, what is going to be the output? The output is going to be 10. Did you understand?
Yes, sir.
Okay. So
Yes, sir. Yes, sir. Yes, sir.
so if I write int star p, this has a separate meaning. Now if I write star p after that, that means has a separate meaning. This is being used for declaring a pointer variable. Here this is being used as a dereference operator. This is being used as a dereference operator. If I do a into b, this is being used as an arithmetic operator to multiply. So this star has got three meanings, and that is why it makes this concept of pointers so confusing, because people don't understand these three meanings clearly, and they tend to merge each other. So one way of looking at it, this is a simple case where your star is being just used to, like for example, when you're writing sentence, no, you are writing some sentences and you suddenly find there is one complex word, that you don't understand, and then you want to make a note of it. So what do? You put a star there and you write a star here and say that, okay, the meaning of this is something, right? When you're writing in your notebook also, if you want to highlight something, you will put a star. So this is, in that context, it is being used. That pointer, this p val is a pointer variable, so I'm highlighting with a star. So this is one context. In the second two contexts, they are being used as operators. Okay, so in this case, when we are using two operands, that means this star is being used as a binary operator. Okay, star is being used as a binary operator because there are two operands. So when you have two operands with a star, this behaves as a binary operator. But what does it do? It does multiplication. So it is used as a arithmetic operator, multiplication. But when the star is used with a single operand, that means there is only one operand to the right, then what does the star do? The star behaves like a dereference operator. So it will find out the value which is present in this address p. Okay, so I hope you have understood this entire concept, because this is very important. So here I have 10, Okay, here I have 10 in my memory location, right? And this is basically my address. Now P is holding this address, X is related to this. I can access 10 using X. I can access 10 using star P. This is dereference operator. I hope everybody is clear with dereference operator.
Yes, sir.
Okay, very important concept.
Yes, sir.
Getting a clarity. So star is got three meanings.
Sir, but how will we use this in our program?
We'll use this in the program. I'll show you a program. You can I'll show you a simple program tomorrow where I'll use a so I'll give you a
Okay,
small
okay.
example. It's nothing. You can I'll show you. I'll write a complete program where we will do this. Whatever I'm writing it on a piece of paper in rough. I will write a program and I'll show you exactly how to use this pointer variable. Okay, so I think today we can stop here.
Okay, sir.
If you have not,
Okay,
now
sir.
you can please go ahead and already people have given attendance. Okay, so first thing is attendance. All right, so please give your attendance in case you have not given it yet. And if you have given your attendance, please leave the meeting.